So if we could have our two in-person panelists come to the front, and hopefully Bill can still hear us online to participate in the Q&A. So we have a series of questions from Slido, so I'll start with those. The first one is for Afroza. It's sort of a two-part question. So it says, you have demonstrated a very efficient way to extract water from regolith. So the first part of the question is, what is the total electric energy required to produce the water? And what would be the minimum water concentration in regolith that can be collected that way?
Well, the minimum, the total power, we have only calculated for the ionization part yet. And I mean, I cannot remember right now the number, but that was already proposed during the proposals. And but for the second one is that the minimum sublimation rate, that is also we have left for the integrated test. So we didn't test that yet, that what is the minimum requirement of the sublimation test to collect that amount of water.
Okay, thanks. And so the second sort of two-part question is for Bill. Is there any more thermal work necessary for such extreme cold temperatures where Viper would be landing? And do the passive thermal control systems presented have fail-safe or fail control methods?
Oh, okay. I mean, we are going to be testing those down to the temperatures that is going to be on the moon in a thermal vacuum chamber. So be able to show that. Basically, what I didn't show when we discussed the Viper is that we have each loop heat pipe is collecting heat from one panel, but there are also a series of constant conductance aluminum ammonia heat pipes that transfer heat from one panel to the next. So there's one going in each direction from each panel to the adjacent two, so that if one panel fails, one loop heat pipe fails, the constant conductance heat pipes will transfer the heat to the other three operating heat pipes, loop heat pipes.
Okay, thanks. And our last, or one of the additional sort of two-part Slido questions is for Teresa. Do you have indications that woven Kevlar will hold up against lunar regolith or dust? Are there plans to test this design with lunar stimulant?
We do plan to test it with lunar stimulant. We have purchased some LHS-1 from the Exolith lab, and with the attachment of the tread to the prototype, we will put it in a containment with the lunar soil and do a drawbar pull test to determine its reaction with those conditions.
Okay, thanks. And so another sort of, this is a broader question, thinking about proposal writing and you all as Space Tech awardees, what would be the main piece of advice that you might give someone who would like to or is currently writing a proposal for funding to one of these Space Tech programs? We'll start with Bill online.
Well, basically, this is a sequential NASA Phase 2, which requires other SBIR or STTR programs you've done before it to get funded. So basically, in our case, it was just being involved with the NASA SBIR program to develop thermal devices for the moon.
Bill, did you cut out or was that the end of your answer?
That was the end of my answer.
Okay, thank you. Teresa?
One thing we did in our proposal, where I don't know if it actually helped, but it was something I specifically told the students to do, was throughout the proposal, we referenced the most current taxonomy report that NASA had produced and demonstrated where within our proposal, we were fulfilling different aspects that NASA was looking for as indicated within that report.
Okay, and
I'm also new in this area, but in this case to work with NASA. But what I have understood so far is that looking at different challenges that, for example, LSIC is presenting in different areas is one of the good idea to look at the challenges and take this associated steps to write the proposal, because sometimes different ideas are in mind, but it doesn't happen because we don't know where it can fit. So this is a better idea, or maybe the best idea, to look at these different challenges. And also, this is not only the LSIC, there is some other sources associated with NASA. They also provide that kind of challenges throughout the years. So looking at those resources is also helpful before writing the proposals and get funded.
Okay, thank you. So going back to Slido, a question for Teresa. I guess it's sort of like another materials related question. Kevlar is a very high outgassing material. How do you mitigate that for vacuum testing?
We haven't thought about vacuum testing at this moment. We were focusing very much on just the actual mobility of the technology. When vacuum testing does come up, materials can be changed. I mean, we 3D printed everything with PLA, which you cannot put in the vacuum chamber as well. So the material selection is very much an ongoing progress. And so the Kevlar may very well be swapped out or further evaluated to see its effects in that type of environment.
Okay. And another question for Bill online. What was your personal largest challenge in the robot you made? So I guess your greatest challenge in making your robot.
Well, we did not make a robot. Sounds like the question was for somebody else.
Okay, can you talk about the biggest challenge then in just in your project in general?
It's basically been trying to develop things with kind of supply chain problems. We're having a lot of delays and getting materials and all the rest, and having to overcome those. Been doing that well, but that's kind of been the biggest challenge.
Okay, thanks. And so sort of another general question. I noticed, Afroza, in your presentation, you talked about the Gantt chart and sort of thinking about structuring your proposal. So could you maybe give any advice or any useful knowledge about how hard it was or easy it was, I guess, to stay on track using that kind of tool? We'll start with you, and then maybe the other panelists can also chime in on that one.
Yes, it was very hard, especially whenever the project was running during the COVID, because there was a really big issue with the supply chains. For example, the hollow cathode test we wanted to do, and it was broke, and we sent it to vendor, and it didn't come back now. So it is 6 months, almost more than 5 months. So these type of challenges are really were there, and it made very hard to achieve the Gantt chart goals, according to the Gantt chart goals. Another thing is that it is always a good idea to think ahead of the time, because you can put always the purchase order before it needed. So that's why this is one of the aspects, was that to keep on track, most of the time we had to think even the last part of the project, because okay, how we can put that in together, even we don't know what to do with the first part of the project. So that was one other helpful idea, or the steps we took to put the whole project on track.
Okay, Teresa, any feedback?
Yeah, that pretty much everything that was just said, with the addition in the environment that my team was working, we are nearly all undergraduate students going through different seasons throughout the year of within the semesters, and then with summer semesters. So having to cater towards all these outside influences with people's education, personal lives, and personal hurdles. It was difficult to keep on track with our Gantt chart, adding to the supply chain issue, and needing to move away from our original idea of what we were building our technology off of, certainly put a few wrenches in the plan.
Okay, and Bill?
Well, again, as I said, supply chain issues have been a lot of the problem, and also large delays and vendors returning things to us.
Okay,
That's
and
it.
sort of, oh, go ahead.
No, that's it.
Okay, and sort of on this theme of challenges, and you've all been able to sort of demonstrate how you've overcome them. For Teresa specifically, a Slido question is, do you think you were able to make a superior design with the components you found despite those electronic shortages you mentioned in your presentation due to COVID?
I believe so. I think even if we had been able to go down the route of using the ODRI, with the capabilities that we are looking to have our prototype have, there would have needed to be, especially to that lower leg appendage, significant design changes that would have led to more changes. So I believe since we ended up starting from the ground and working our way up, we were able to cater absolutely everything towards our final goal of the different terrains that we're looking for the modality to operate in. It certainly isn't superior in terms of timeline, but I think our end product will be a lot more catered towards what it is supposed to be doing.
Okay. And another question for you, Teresa. You mentioned the next steps being the development and testing for the lunar viability. Can you talk a little bit more, give more specifics about that?
Yes, so we have preemptively now, but we have built our own miniature slope lab in the lab. It's a giant sandbox, 3 feet by 13 feet with an articulating base of up to 45 degrees. With the development of a prototype, that will be one of the first environments that we'll test it in. We are using safe sand in there because EHS got mad at us when we told them we were going to fill it with simulant soil. But we will be able to test it in, a looser gravel with an articulating base at different degrees and qualitatively analyze how well it performs in those. For the icy content, we do have lunar simulant soil that we plan to freeze and test within a more contained environment, and also just put the prototype directly on a sheet of ice. We plan to go to an ice rink to do that, and again, analyze how it reacts in that environment.
Okay, thank you. And one more question for Bill. You talked about the Viper mission. Was that part of your proposed work? And if not, how exactly did you all get involved with Viper?
Well, as I said during the talk, we have been working with both NASA Marshall and NASA Johnson for the past 12 years to be developing kind of devices for surviving the lunar night. So Viper was not part of the sequential phase 2 program. It was a spin-off of an earlier NASA SBIR to look at hybrid wick heat pipes for operating on the lunar surface. One of the things that's different on the moon than in space, everything pretty much is microgravity. And when you test a device on Earth, typically you're testing it almost level. With the moon, with a lunar lander, it can land kind of 20 degrees tilted in any orientation, and a rover, as it travels around, can go up to 45 degrees slope in any direction. So you have to accommodate that, and that's what we had worked on in the previous SBIR, and we had a NASA phase 3 to develop an engineering demonstration unit, and did that. And now we followed on with that with the flight hardware.
Okay, thank you. And sort of in an effort to keep on time, I'll ask one more sort of like general question. I think pretty much everyone gave a little bit of background about the future work and future steps, and you all are successful space tech awardees, but is there anything you might do differently or you would have done differently when you were writing your proposals, or maybe thinking about the next one you would write, anything you would do different or maybe better? We'll start with Rosa.
Yes, whenever any of the proposal comes in and get funded, we do the work. And during the time period of work, we always feel like, okay, it could be done in a different way and a better way. So the things happen since that's how we propose the next steps to go ahead with a better understanding and with a better approach.
Teresa.
I wouldn't change it, but if I were to do something similar again, 22 students is a lot of students to organize when you are also a student. I'm proud that anyone who wanted to joined this team and got the experience. If I did something else after this, I would look for more specific skill sets or people interested in developing specific technical skill sets to work on the project.
Okay, and Bill online.
Yeah, this is a very unique opportunity for us. I mean, we do a fair number of normal SBIRs with NASA, where they're responding to their list of topics. In this case, the sequential phase 2 SBIR program, I don't think is held very often. So really, I don't expect we're going to actually respond to another sequential. We're probably going to go back to responding to normal SBIRs.
Okay. Thank you all so much for being on the panel and answering questions. If there were any questions on Slido that anyone did not get an answer to, we will make sure to try to follow up with our panelists, try to get some answers for you all. So thank you so much for listening into this panel.